Hello people, as promised, I've opened the capacitor welder box up, show you what's inside. This side here is the actual primary side. Yes, it is exposed, but I assure you it's pretty safe once the lid's on. You've got two secondary 15 volt outs. One side of the 15 volts feeds a power supply, which is set to around about 15 to 15.5 volts. Using a voltage regulator LM723, which has also got current limiting, but I've left the current to max. There's a power transistor in there to up the amperage up to about 15 amps as and when required. I mean, you're only using short bursts of high amps to charge your cap, so that does the job fine. And there is the actual timer circuit. Again, it's got its own voltage regulator. You've got a trigger on this side, which triggers the actual IC into counting. The trigger is basically these two wires coming off, and they go onto the thyristor, basically, which is that thing there. And that trigger is one of these buttons here, in there. Okay, right, let's put it all back together. There's a 1.5 volt battery in there, by the way. That triggers the thyristor. Right, that's the PCB back in. Okay, I'll show you the schematics, and that's about it really. Right, hello, we have the circuit diagram finally. I've managed to cobble together the circuit. It's two individual circuits linked together. You've got a transformer with two primary outputs rated at 15 volts. Either side of the primary powers the two individual circuits. The first circuit at the top is a voltage regulator, the power supply to charge the capacitors. Basically what you've got is one primary coming out, transformer, into the bridge rectifier, and then obviously it feeds the circuit at the top. I'll go through the circuit with you now. Certain pins on the chip aren't connected, so the label there. You've got a power transistor at the top, which is a 2N3055. You've got a 10 watt resistor, 0.47 ohm. Power diode. Now the one I happened to have lying around was a P600 rated at 6 amps, but you can have, well, you can go as high as you want really with the diode. Surge is a lot more than 6 amps on the diode, so that'd be fine. You've got a 100 ohm variable resistor, 10 ohm resistor, 1.5 kilo ohm resistor, 47 microfarad capacitor, 4.7k variable resistor, and a 470 ohm resistor there. And you've also got, I think I've covered the 47 microfarads. You've also got the 4.7 nanofarad ceramic type capacitor here. Okay, so let me just scroll around so you can, sorry I haven't gone over all the lines. When I drew this up on the computer I couldn't quite get the wires to come out thick, so that's the connections there. I'll try and go as slow as I can. Obviously feel free to improve on the design. This is a very crude basic design, but it does work. I wish I could actually take a snapshot of the complete diagram, but what I've done is I've actually enlarged it So I've had to print it out on 2 separate pieces of paper and then tape the paper together. Right, so there we go. That's the circuit diagram for the power supply. Now then, what you've got on the bottom side is the actual timer circuit, and the timer circuit again has got its own bridge rectifier. Again, it's supplied via the transformer, 15 volts. You can actually adjust the voltage. I've actually set mine to around about 12 volts, but you can have up to 15 volts. Bear in mind it will affect the timing, so you can tweak the voltage. Well, what I did before I put the actual IC circuit together, the actual 555, is I actually power this part of the circuit here, and measure the voltage with a voltmeter. That's the potentiometer you need to use there, which is a 1K, and that sets the voltage. Set that to 12 volts, and then you can plug in the IC 555 and you're ready to go. Right, so what you've got now is a power supply on the one side. Let's just get into there. You've got a smoothing capacitor there, 4,700 microfarads. You've got a 100 nanofarad ceramic type capacitor. So that's basically your power supply side. And then you've got 100 ohm resistor there, another 100 nanofarad capacitor, 47 microfarad electrolyte type. You've got a 22 microfarad capacitor, electrolytic type. That governs the timing with this resistor here, the 470k resistor coupled with the capacitor governs the time period. And there's your 555 timer. Zoom into the pins. That one there at the top is pin 4 on the left. Then you've got, try not to shake the camera, pin 6. Pin 5 is not connected. Got pin 2, pin 1, 8, 7 and 3. Blow that muck off there. It's got an LED to indicate the charging side, the timer side should I say. And you've got a general purpose transistor which operates the relay. Now then, let me just hold that there so you can try and make sense of the circuit. Okay. Now this switch here is a little tactile switch which starts the timing cycle. There is also another switch which discharges the thyristor through using a 1.5 volt separate battery. Right, so to start from the beginning, you've got transformer. One side of the output feeds the actual power circuit for the charging of the capacitor. The other side there's the timer circuit. Now the bit that gets a bit awkward is here. I've tried to clarify as much as I can. Right, the two heavy lines here, these are your probes. That's your thyristor, and these are the big capacitors, totaling 2 farads. Okay, and the capacitors are linked directly to the probes, and the only thing that's stopping them discharging is a thyristor. And the thyristor is controlled via a relay. Now if I can show you this side here, the timer actually controls this relay. Once the relay activates, it pulls the contacts over here from normally closed. Hang on, let's get that right, normally closed yet. It flips the contacts over, so now you've got charge coming from the positive rail at the top, running down. Don't forget the relay's on. switches over, so it's through the switch, out the switch, or should I say the relay contacts, down and into the positive side of the capacitor. Okay, now the negative side is connected to the negative rail on the power supply circuit. So it's getting its negative here, positive is switched via this relay. Now when the timing period of this relay is up, this relay then opens again. In effect it breaks the circuit. So the capacitor's now had its charge. Now what we've got to do then is obviously discharge. The way you discharge it is by using a 1.5 volt battery, and the battery is connected through the secondary contacts on the relay. So when this is in the charge phase, when that relay is active, you can't discharge the thyristor or the capacitor through the thyristor, because the gate is not getting a positive feed here. If that contact there is over, by pressing this other switch you cannot get a positive feed coming down here to activate the thyristor. I hope I'm making sense. I haven't rehearsed this, so it's pretty straightforward. The battery basically switches on the thyristor. The battery is pulsed via the other tactile switch, but you can't discharge when this part of the relay is in the charge cycle. Okay, I think that's about it really. Hope it makes sense, and if you do give it a try, let us know how you get on. Obviously it's been a long time since I've built this. It's practically been about 6-7 months, and I've just had to re-jog my memory, trying to remember which way around everything's connected, but I'm pretty sure this is all good. If you find any flaws, please give me a shout, and I'll rectify it immediately. But let me just go once over on the circuit. It's a 1K variable. Obviously you've got a protection diode across the relay, stop any spikes. That's about it really. See if I can obviously switch 1 and the other switch here, switch 2 and switch 1, I've actually mounted them on the actual probe itself, so you've got finger control. Right, so this is my first attempt at making a capacitor discharge welder. I've already experimented with a pickaxe microchip, and hopefully I'll be developing pretty soon a pickaxe version, which will be microprocessor controlled, and that will have all sorts of variables in there which you can punch in and hopefully play around with. You can control the gate on the thyristor very precisely. Okay, thank you for watching.